34C more or less from 5.2. So you are supposed to say, they tell you, if A and B are real numbers, define e to the alpha plus beta I as e to the alpha times e to the beta I.
Well, in other words, just use a rule.
Okay, yeah, you like use an exponent rule, right? And then you know from Eulers that that's e to the alpha times the quantity cosine beta plus I sine beta.
Yeah.
Oops, sine, not
Sine.
sim. Okay, and then they tell you, show that if z1 is a1 plus I b1, a1 plus I b1, and z2 is a2 plus I b2. So if this,
It's like a fractal.
use this to show that e to the z1 plus z2 is e to the z1 times e to the z2. Right?
Yeah.
Which is just the exponent rule, right?
Right.
And so you're all like, duh, exponent rule? Okay. Thing about exponent rules, you don't actually know they work for complex numbers. So this is demonstrating that they actually do work for complex numbers. Right? So you gotta be like, alright, so in order to demonstrate something like this, just like in part B, you gotta start with something you know, or something you have, and get to the other side. So you're gonna start here, pretend you don't know that, and get over there.
So just do what we did in part A.
Yeah, so you're going to start with e to the a1 plus I b1 times a1 a2 plus I b2.
Wait, plus.
Plus.
I'm like, I know, so that's part E.
Plus.
E for Euler.
Like that. Okay, and then you're going to try to fit this into Eulers, right? You'll be like, alright, so that's e to the a1 plus a2 plus I times b1 plus b2.
Which you could just.
And really, you should have some justification for that step. So what's the justification for that step?
Combining parts and
Adding
complex numbers.
and factoring.
Yeah, so that amounts to, because addition in the complex numbers is both associative and commutative.
By the equivalence.
What equivalence there?
Addition in C is nice, right? Okay, so that would be something that you would have to demonstrate on its own, but you can assume that here.
Right.
So switch like this, and then you notice, okay, so this thing,
Is A naught plus I B naught.
yeah, so that's A's and B's, right? With an I in between. So I can use this part, right, to say that e to the a1 plus a2 times the quantity of cosine of b1 plus b2 plus I sine of b1 plus b2. Right? Why is that true?
Use nice tree up there.
Yeah, so do something like this. Note. And then what?
Like
Then you
distribute
use
the
this sum.
cosines, kind of.
Then use the angle.
Yeah,
sum
so
like
now
you
you need this
cosine.
sum of angles identities.
Oh.
And you have those because they were in part B. Right, so just go look in part B and get them out.
You just memorize them.
And then once you've got that, then you do a little clever factoring and see this thing. Really, you'll have to see Eulers backwards here. So you might want to think about what Eulers done to this would look like. so that you can see it backwards.
What you're saying.
And I'm gonna let you guys finish that, is that okay?
Yeah.
Wouldn't it be easier to go on the start on the right side?
Yeah, so that's a valid thing, like, okay, so I did this might be the hard way. Sometimes when you get stuck in one of these, start with the other side and push that along. Do try to avoid this thing, where you're like, left-hand side is, right, like, working with the left-hand side there. Right-hand side is, and then get like, oh, this thing and this thing are the same? So check, right? Try to avoid those. Really, you should go from the left-hand side straight to the right-hand side, or from the right-hand side straight to the left-hand side. But the manipulating them both until they're the same is a kind of a crummy technique. If you do that, the right answer is to rewrite it as do these arrows down, and then go to that one and back up. Right, so you'll have to rewrite the whole thing, but you can use this as a motivation. Okay, see that? So proofs really should flow from one side to the other, not both sides and then meet in the middle.
I mean, is it technically wrong though?
It's not wrong, it's just much less convincing.
No style.
Yeah.
Yeah, it's basically just bad style points. Like, you're not gonna get a kudos for that. You're gonna get a little.
Right.